In this video, we will be covering how to control the MD800 VFD through EtherCat communication. In order to do so, we are going to need the MD800 EtherCat expansion card. The part number for the card is SIECAT, and it can be purchased from our website, which will be linked below. For our controller, we will once again be using the Inovance EZ523 and using the AutoShop program to control the drive. This controller is available for purchase on our website. The AutoShop program can be downloaded for free from the Inovance website as well as from our own website. You can also use any other controller that supports EtherCat communication. Firstly, we will install this card into our drive. Start by removing the blank card with a flathead screwdriver and slot in your SIECAT card in place of it. Once installed, we can now power up the drive and begin configuring the drive parameters. The first step is to configure the drive for our motor. We have covered this topic in our quick start video. Please check out that video and return once you have completed the auto-tuning portion of the video. Once you have completed that part, we will begin with configuring each axis for EtherCat control. We will start with axis 1. Start by pressing the program button, navigate towards the F0 field, and press enter. The first field we will change is F0-01. This is the motor control mode, which is voltage over frequency by default. The MD800 also has options for sensorless vector control and speed control for synchronous motors. In this example, we will stay with voltage over frequency control. The next field, F0-02, is the parameter for the control source selection. For this, we will select the option for communication control, as we want to be utilizing EtherCat communication to control this axis. Similarly, for field F0-03, we will set the value to 9 in order that it can be adjusted via communication. The final parameter within F0 would be F0-12, which is the maximum running frequency of the motor. Remember to repeat this step for each applicable axis. In this next section, we will focus on configuring the communication for EtherCat for the MD800. These parameters are all set on the power supply unit, so ensure that the axis number is showing 00. Press the program button and navigate up to the field FD. The field, FD-10, controls the communication type that the drive uses. Since we are running from the communication card slot, we will change this value to 3 and press enter to save. Finally, we are required to cycle the drive's power in order to apply the current communication settings. Finally, we can begin programming the drive. As stated earlier, we will be connecting to the drive from our EZ523 PLC and programming the controller through AutoShop. We have started a new project file and have established communication with our controller already. The first thing to do is to import the .xml file into our program. The .xml file can be downloaded from the Inovance website, which will be linked in the description. On the right-hand side, under Toolbox, we will right-click EtherCat Devices and click Import Device XML. Once you have selected the right .xml file, the next step will be to add the device into our project. The easiest way to do this is to head over to the project manager on the left-hand side and head down to EtherCat. Right-click on it and select Auto Scan. A window will pop up in which we can click Start Scan to begin scanning for all EtherCat devices that are connected on the same network. Once the scan is complete, we will click on Update Config, which will import all of our EtherCat devices into the program. The next step is to adjust the settings of our MD800 to match our physical layout. To do this, we will need to open the device settings by double-clicking on the MD800 device that was just added to our program. We will then click on Process Data, and here we can see that we are able to add up to 8 axis inputs and outputs. For our example, we are only using 2 axes, so we will select only one more input and output. The next tab we should look at is the I/O Functional Mapping tab. This is where we can view all the relevant variables for programming our drive. there should be 4 tags for each axis that you have added to your project. So in our example of 2 axes, we have 8 available variables. This table that can be found in the manual will show you the data to be sent or being received and what each value represents. We will send data to the command variables and monitor the axis status by the input variables. As you can see, whenever we modify the output values, we can observe changes in the drive behavior. We can also track and monitor changes to the input values as the state of the drive continues to change. This has been a guide to configure the MD800 inverter drive with EtherCat communications. Please check out the other videos on our channel for more ways to set up the drive or help setting up other Inovance devices.